Welcome back to the Deep Dive. Today we are tackling a subject that, well, it usually puts people to sleep right up until the moment it gets them fired.
That's one way to put it.
We're talking about cloud security, specifically Microsoft Azure. And before you tune out thinking this is just for the tech crowd, let me frame it differently. You know that feeling when you lock your front door, you walk away, and then halfway down the street you think,
Did I actually lock it? The universal panic.
exactly.
Yeah.
Now imagine your house has 5,000 doors and windows
Yeah.
and, a few skylights you didn't even know were there. That is basically an Azure environment.
That's a pretty good analogy.
And we're working from a document today called Azure Penetration Testing, a complete guide for 2026 by Ankit P. from AppSecure. And the core idea here is unsettling. It basically says Microsoft built you a bank vault, but you're the one who decided to tape the combination to the front wall.
It's blunt, but it's dead on. It all comes down to something called the shared responsibility model.
Right.
And we have to get this straight. People hear cloud and they assume, okay, Microsoft has armies of security engineers. They've got retinal scanners at the data centers. I'm safe. And yeah, the physical server is safe. Nobody's breaking into a Microsoft facility to steal your hard drive.
Mission Impossible style, yeah.
Exactly. But Microsoft controls the pavement. You control the car. And if you drive that car off a cliff because you didn't, configure the brakes properly, Microsoft just watches you fall.
So they secure the infrastructure.
They secure the infrastructure. You secure your data and, crucially, your configuration. And that's where the wheels come off.
And that's what we're digging into, the
Yep.
human side of it all. The guide makes it clear the biggest risks aren't some complex zero-day exploits. They're simple, avoidable mistakes. So let's start there. Azure has tools, right? Defender for Cloud, Sentinel, all these automated scanners. So why do we need a person, a penetration tester, to try and break in? Why isn't the software enough?
One word, context. That's it. An automated scanner is, it's dumb. It's really good at matching a checklist. Is port 80 open? Check. Is this version of Linux out of date? Check. But it has no idea about intent.
Give me an example of what you mean by intent.
Okay, take a storage account. A scanner sees a blob storage container is set to public. It flags it. Big red warning.
Right.
But maybe you're just hosting the images for your public website. In that case, it needs to be public. The scanner doesn't know that. It just screams, warning.
And then you get alert fatigue and just start ignoring everything.
Precisely. A human hacker or a pen tester looks at that same open container and they check the contents. If they see logo.pnd, they move on. If they see database backup.bake or Q3 invoices.pdf,
They've hit gold.
they've hit gold.
Yeah.
They understand the business logic. It's the difference between a spell checker and an editor. One checks the rules, the other checks the meaning.
That makes perfect sense. Okay, so let's get into the meat of this guide, top risks. And number one, by a mile, seems to be storage accounts, specifically something called a SAS token.
The silent killer.
Break this down, because shared access signature sounds secure. I mean, that's got signature in the name.
And in theory, it's a fantastic feature. Think of it like a hotel key card. You don't give a guest the master key to the whole building, right?
Ugh.
You give them a card for room 204 that expires at 11:00 a.m. A SAS token is that. It's a string of characters you add to a URL that gives limited access to a specific file for a limited time.
Okay, that sounds pretty secure. So where's the problem?
The problem is how people use them. A developer's writing a script, they need to back up some data, they generate a SAS token, but they don't want it to expire while they're testing, so what do? They set the expiration for, the year 2030.
So now we've got a 10-year key card.
Yep. And they're not sure what permissions they'll need, so instead of just read, they check the box for read, write, list, and delete.
The master key.
Basically. And then, and this is a classic mistake, they hard code that super long token right into their code. And then they push that code to GitHub.
And it's public.
Now it's public. And here's why it's so dangerous. The guide calls it silent exfiltration. If I steal your password and log in from, say, Russia, your security system might flag that, hey, weird login location.
Sure.
But a SAS token, it's a valid key. It doesn't trigger a login event. It doesn't look like a hack. It just looks like authorized traffic. I could be siphoning your data for months with that one token, and you would never, ever know.
That is terrifying. The ghost key, you wouldn't even know who used it.
Exactly. You just see data leaving.
Okay, so storage is a minefield. What's next?
The backbone of everything. Identity. We're talking Azure Active Directory or Entra ID now. The guide mentions identity sprawl. Is that just too many people with passwords?
No, it's actually humans are becoming the lesser problem there. The bigger issue is the non-human identities, service principals.
The robots.
The robots, basically.
Yeah.
When you build an app in Azure, say a web app that needs to read from a database, you create an identity for it, a service principal, so the app can authenticate without a person typing a password.
Okay, standard stuff. Totally standard. But again, convenience versus security. A developer is building something. They want it to work now. They hit a permission error. They don't want to spend 3 hours figuring out the one specific granular permission they need, so they do what?
They just click Select All.
They grant the service principal contributor access to the entire subscription,
Yep.
or directory reader to the whole tenant.
So the app has admin rights.
Effectively, yes. And here's the attack path. The hacker finds a flaw in your web app, maybe a SQL injection. They compromise the app. If that app had low-level permissions, they're stuck. But since you gave it contributor rights,
They now have those rights. You become the robot.
I become the robot, and I use that robot's privileges to create a brand new user for myself, give it global admin rights, and now I own your entire cloud. It's a primary escalation path.
So the theme here seems to be make it work now, secure it later, and later jest.
Later is a myth in IT. It never comes.
Let's talk about the plumbing then. Networking. I feel like this is where the old school IT folks get a little overconfident. I've been managing firewalls for 20 years, but the guide says basic network security groups, or NSGs, are still a huge problem.
It's the classic any problem.
Allow any IP to talk to any port.
Yes. And it's almost always done during troubleshooting. I can't connect to my server. Let me just open up the firewall for a second to see if that's the issue. And then they forget. Or go to lunch.
And suddenly RDP, the remote desktop protocol, is open to the entire world.
Port 3389. The guide is very blunt here. If you leave RDP open to the public internet, it's not a question of if you get attacked. It's minutes.
Wait, really? Minutes?
Minutes. There are botnets that do nothing but scan the entire internet for port 3389 24/7. It's just background noise.
Yeah.
You spin up a VM with that port open, you'll see login attempts almost immediately.
So you're basically hanging a neon sign on it.
Absolutely. And once they brute force the password, which is easy if you don't have MFA on that entry point, they're inside your network. And from there, they can pivot.
Pivot. That brings us to the new stuff. Kubernetes, AKS. The guide flags this as a huge blind spot because people hear managed service and think Microsoft handles all the security.
That is a massive, massive misconception. AKS is managed in that Microsoft handles the control plane, the brain of the operation. They patch it, they back it up. But the worker nodes, the actual virtual machines running your containers,
That's on you.
that's your problem.
So what's the typical vulnerability there?
It's often the kubelet API. The kubelet is an agent on each node that takes orders from the master. In a lot of rushed setups, that API is exposed to the network without proper authentication.
So if I can talk to the kubelet,
You can tell the node what to do. You can say, run this malicious container for me. Or even better, give me all the secrets from this other container.
and secrets means API keys, database connection strings.
The whole shebang. And this links right into serverless too. Azure functions. Developers love them. They're quick to deploy. But where do they store the secrets the code needs?
Don't tell me they hardcode them.
Sometimes. But more often, they put them in environment variables, which sounds right. It's better than in the code. But if an attacker finds any way to inject code-like through a website form that isn't sanitized, they can just ask the environment to print all those variables.
And the function just hands over the keys.
Here are the database credentials. Have a nice day. It's basic input validation, but the impact is immediate.
What's so chilling about all of this is that the system is just doing what it was told. It's not broken, it's just obedient to a bad command.
That's the perfect way to describe it. The cloud is an amplifier. It amplifies your code, your reach, and your mistakes.
So we know the house is full of open windows. We hire a pen tester. But I was surprised to read they're really strict rules. You can't just go scorched earth on your own cloud.
No, absolutely not, because the cloud is multi-tenant. Your server is just a slice of a physical machine that might also be running a hospital's application or a bank.
So if I try to DDoS my own app to test it,
You might crash the physical hardware supporting that hospital, which is a huge no-no. So Microsoft's rule is firm. No denial of service attacks, period.
that makes sense. What about social engineering? Can I hire a firm to, I don't know, call up Microsoft support and pretend to be me?
Nope. No social engineering of Microsoft employees. And you can't attack the managed services themselves. So you can't try to hack the Azure AD login page. You can only test the things you built.
Okay, so within my own kingdom, it's
fair game.
Okay.
And interestingly, you don't even need to ask for permission anymore for most tests. You just do it.
Let's get into the mindset then, the how. The guide talks about the difference between a scan and a real pen test using something called vulnerability chaining. Can you walk us through their example? Because that really clicked for me.
This is the aha moment. A scanner finds a list of disconnected problems. A hacker finds a path. So the scenario starts with reconnaissance. The pen tester uses a tool like PowerZer or Microburst to map out the environment. They find a public code repository, maybe a developer's personal GitHub, and what's in it? A SAS token.
We're back to the SAS token.
We're always back to the SAS token. A scanner might flag this as, medium risk, but the hacker uses that token. They get into a storage container. Inside, they don't find customer data. They find a config file.
Okay, still sounds kind of boring.
But inside that config file are the credentials for an Azure Function app. So now they have access to that app. They check the app's identity, its service principal, and they realize this app has the user access administrator role on the subscription.
Oh, I see where this is going.
The hacker uses the app's permissions to create a brand new user for themselves. Then they use the same permission to promote that new user to global admin.
So they went from a single text file on GitHub to owning the entire company.
That is vulnerability chaining. 3 low or medium risks that, when connected by a human, equal a catastrophic breach. No automated tool can see that story. The tool sees 3 issues. The human sees a key, a door, and a vault.
That's genuinely scary. It really shows why you can't just trust a green dashboard.
A green dashboard is often a lie.
So when should we actually be doing this kind of testing? Is once a year for compliance enough?
The compliance answer is once a year. That's for your SOC2 or your HIPAA audit. But the guide makes a great case for event-driven testing.
What kind of events?
Big changes. Just migrated a legacy app to the cloud. Test it. Just rewrote your infrastructure as code templates. Definitely test it.
Because if you mess up the template,
You replicate that mistake everywhere, instantly. If you have one typo in your code that opens port typo 2 and you deploy that to 50 servers, you just opened 50 doors. That's a trigger for a test.
the guide also pushes for a different style of testing, not just black box, where the tester knows nothing.
Yeah, in the cloud, that's just inefficient. The guide advocates for gray box or white box. Give the tester the architecture diagrams. Give them the docs. You want them finding the deep logic flaws, not spending 3 days just trying to figure out what your domains are.
And I love this point about CESO collaboration.
It's huge. Normally, you hide the pentest from your own security team to test them, but this guide suggests feeding the live attack logs to your defenders as it's happening.
So the hacker says, okay, I'm about to try and elevate my privileges, and the security team watches their dashboard to see if an alarm goes off.
Exactly. It tunes their detection. If the hacker gets in and nothing blinks, you know your monitoring is broken. It turns the test into a live training exercise, not just a pass-fail exam.
Speaking of which, we have to mention the invisible risk from the guide, logging.
Yes. This shocks people. In the physical world, if someone breaks in, they might leave fingerprints. In Azure, if you haven't explicitly turned on the right logs, there is no record.
So an attacker could get in, steal everything, and leave, and you'd have no proof it ever happened.
You are flying completely blind. You can't do forensics on data that was never collected. And a lot of services don't log everything by default because, well, it costs money.
So you save a few bucks on storage and lose the company.
It's a bad trade-off.
So zooming out, the big takeaway here for me is that the cloud isn't some magic safety blanket. It's a power tool.
A very powerful tool with no safety guard. It just assumes you know exactly what you're doing.
Which brings us to the final thought to leave you with. And it's a bit paranoid, but I think it's justified.
I want you to think about your company's code base right now. Somewhere in your Git history or in a comment in a test script from 3 years ago that nobody's touched since. Is there a SAS token?
The needle in the haystack.
Is there an old service principal with contributor rights that nobody uses anymore? Because if there is, the lock on your front door is wide open. And the only way to know for sure is to try and break in yourself.
Before someone else does.
Exactly. Better to pay a pen tester than a ransom.
The sobering thought. Check your configs. And maybe reread that shared responsibility model.
And for goodness sake, turn on your logs.
That too.
Thanks for listening to The Deep Dive. We'll catch you next time.